everyone, my name is Lucky Chidupali, and today we are going to be going over some SAT math practice problems from the College Board SAT Practice Test 10 from the No Calculator section. We will be going through all of the questions in the test, so this will be the first part. So in the SAT, the problems usually start out easy and progressively get a little bit harder. So here we're starting from the beginning because this is part 1. So our first few questions may be really easy or easier than normal. So our question is 2z plus 1 equals z, and what value of z satisfies the equation above? And our options are A, -2, B, -1, C, 1/2, and D, 1. So basically, let's write out the problem first. 2z plus 1 equals z. So what we want to do is isolate z by itself. So in order to do that, we'll subtract 1 to the other side. So now we have 2z equals z. Let's put a dash there so we don't confuse anyone. 2z equals z minus 1, and now we can subtract z to both sides. So 2z minus z would just be z equals -1, and that would be answer option B. Now our second problem is a television with the price of $300 is to be purchased with an initial payment of $60 and a weekly payment of $30. Which of the following equations can be used to find the number of weekly payments, W, required to complete the purchase, assuming there are no taxes or fees? So in order to solve this problem, or in order to explain it, first let's write down all the components we have. So the television price is $300, so the total payment is $300. We know that the initial payment, like it says here, initial payment is $60. And we know that there's a weekly payment of $30. So now the question wants us to find the number of weekly payments, W, required to complete the purchase. So basically, the initial payment plus the weekly payment should equal to the total payment. So we can create an equation here. So let's say $300, or actually let's just place it as 300, equals, equals the initial payment, which is 60, plus the weekly payments, which are $30 each. So we can use W as our variable. So our equation right here correctly depicts this problem, so our answer option would be C. Next, for our third problem, we're given a sort of chart right here, and the problem says, the table above shows shipping charges for an online retailer that sells sporting goods. There's a linear relationship between the shipping charge and the weight of the merchandise. Which function can be used to determine the total shipping charge, f of x, in dollars for an order with a merchandise weight of x pounds? And our options are A, f of x equals 0.99x, B, f of x equals 0.99x plus 11.99, C, f of x equals 3.39x, and D, f of x equals 3.39x plus 16.94. So first of all, the form of our function will be in y, or f of x, because it's a function, equals mx plus b. And we know this because the relationship between the merchandise weight and the shipping charge is linear, where the merchandise weight is X and the shipping charge is Y, or f of X in this case. So here B is the one-time charge. Let's write this out. For shipping any weight in pounds of merchandise, whereas M would be the additional shipping charge. For each additional pound of merchandise shipped. So now, in order to get M, we're going to take 2 points from this table we're given, and we're going to use the delta y over delta x equation. So, for example, let's take the points, let me use a different color. Let's take the points 5, 16.94, and 10, 21.89. Now let's subtract the y, so 21.89 minus 16.94 over 10 minus 5, and that would equal 4.95 over 5. And that equals 0.99. So now, in order to get the B value, we're going to take any one of these points and substitute the point and our M value in order to get B. So, for example, let's take 20, 31.79. So we would make it 31.79 equals 0.99, which is our M, times 20 plus B. So since 0.99 times 20 is 19.8, we can subtract that from both sides. And from that, we'll get 11.99 equals B. So now we have the equation f of x equals M, which we got was 0.99, x plus our value of B is 11.99. So that would be option B. For our next problem, we have a graph and it says the line of the xy plane above represents the relationship between the height, h of x, in feet, and the base diameter, x in feet, for cylindrical Doric columns in ancient Greek architecture. How much greater is the height of the Doric column that has a base diameter of 5 feet than the height of the Doric column that has a base diameter of 2 feet? Okay, so to solve this problem, we're given that the height in feet, so h of x is the height, while the base diameter is x. So x is the base diameter. Okay, so since we have that these points down, so the question's asking how much greater is the height of the Doric column that has a base diameter of 5 feet than the height of the Doric column that has a base diameter of 2 feet. So let's check the one with the Doric column with the base diameter of 5 feet, which is right here. So the height at this point is 35. And let's check for the height of a Doric column that has a base diameter of 2 feet. So here, so right here, it would be 14. feet. So now all we have to do is subtract those two values, 35 minus 14, and that would be 21 feet. So that's our answer. So for our final problem, we have if x is greater than 0, which of the following is equivalent to the given expression? And our given expression is the square root of 9x squared. So basically, we can split up the expression square root of 9x squared into just the square root of 9, and if this is hard, you could do this, or else you could straight away answer it, and just the square root of x squared. So we know that 3 times 3 is 9, so the square root of 9 would be 3, and we know that x times x is x squared, so the square root of x squared, you could just cancel out these two, would simply be x. So 3 times x is 3x, and so that means our answer will be option A, 3x. Thank you for watching, and again, this is only the first part to several parts that will come within this series. I will be finishing all the practice tests and all the problems, so these problems may have been simple, but they will get a little more difficult as we go on. So, thank you for watching. Bye! Make sure to check out my other videos on the SAT topic.